Welcome to Out of the Blank.
Welcome to another episode of Out of the Blank podcast. I have two of my favorite space guests on my show because we're going to learn. Hopefully, well, I'm probably going to learn. You guys are probably just going to talk and be able to know what you guys are saying. Bunch of technical lingo, and then I'm just going to be like nodding my head like I understand. But I had a couple of questions based on my conversations. Heystek, I've known you over the years, and then Andrea, you're kind of new to my show and everything. This is your second time on, but with the idea that comes into space exploration, not only with colonization and space civilizations as well too, but the idea of being able to find out what else is out in the galaxy. Now, I do a lot of UAP episodes, this UFO. I've talked to Massimo Teodorani, who is a astronomer, and he's part of the Galileo Research Project. And we got into lightning ball phenomena and then plasma research as well too, which has me open into this whole new area where I'm like, how much do we know about space and how much are we going to know in the next couple of years? And I start wondering, and I think I'm not to get down into the climate topic, but Heystek, even with the observatory research as well too, you are limited on the capacity of where these locations are based on light pollution. So in a sense, that might hinder some of our progress of understanding more about space because of what we can see through our atmosphere. So I go to a point where if we're learning about dark matter, we're now discovering that that's real. We're learning about other things. I mean, there's a possibility of wormholes out there as well, too. I understand that we're limited in Earth's atmosphere. What about the idea of an observatory on, like, I know it sounds crazy, but on like the moon or on one of these types of maybe planets? I know that seems like a long haul, but I honestly put more weight into human expansion a little bit more. Like people can say, oh, it'll be a 50 years or 100 years. And I'm like, we might get there a little bit faster if more resources are shoved into it. And then I start opening up the door, which is the main question is, if we did put an observatory or we did put a telescope or something on one of these outer, I guess, off Earth, I would say, would our progress in space exploration increase by like tenfold if you don't have to worry about so much light pollution?
Um, yes, I think Heystek is probably the expert on this, on radio telescopes. Actually, it's not a crazy idea at all. It has been proposed, actually. So you're you could consider yourself a bona fide astronomer. It's just a few years ago. It's been proposed to put a radio telescope on the moon, and there's various actually on the dark side of the moon. And technically it's not the dark side, is the far side of the moon, which is we cannot see, but the far side of the moon is perfect for observations of the universe in radio waves, just for the reason that you mentioned, light pollution, but also well, not so much light pollution, but Earth atmosphere, but also any noises and in radio interference. We are very chatty species, so we chat via radio waves a lot. So there's only a few places on Earth we can put radio telescopes, and South Africa is one, the desert in Australia, and in some very remote places on the Earth where there's very little radio communication. And also the atmosphere is it's good for radio observations. But the moon actually is gonna give us, like you say, a tenfold or manyfold opportunities to observe the universe. And one of the targets would be to observe the early universe. So right at the beginning of the universe, this epoch, which we call the Dark Ages, is because not much is going on there. There's no star formation, but there's a lot of there's still gas, hydrogen gas, which inhabits the universe at that point and would emit radiation particularly in the radio waves. And a telescope on the far side of the moon would be ideal to observe that. Maybe Heystek would have something to add on to this.
Yes. So one thing is,
It's correct. There is a proposal to put a telescope on the moon. So if you think about our normal optical telescopes we observe the night sky with, the two most contributing factors is one, light pollution. So you want the telescope as far away from cities as possible, so you have less light pollution. And then secondly, you need to place an optical telescope at a place where the atmosphere is as stable as possible. So for the atmosphere to be stable, it needs to be at dry places and at very cold places. So if the atmosphere is cold, the atmosphere is more stable. And if it's dry, that means less water vapor in the atmosphere. You also have very good viewing possibilities. So that's why, to get away from these issues, that's why these optical telescopes is usually built in deserts or on top of mountain ranges, so you can get above the water level and the atmosphere. There's a few interesting techniques that can help these telescopes to better observation, called adaptive optics, that you can adjust your mirror and lens on the go to stabilize the atmosphere. And you also have active optics that uses almost less the same principle, but use those two principles to stabilize your telescope to get better observations. But in radio telescopes, you have a bit of a more unique problem, because everything causes noise. Your cell phone, Wi-Fi, even electricity causes noises. So you want your radio telescopes at places where you have the least amount of interference. So they will be usually built in valleys or in places where there's no civilization at all. And then the next thing is, your telescope is also important what is designed to observe. So usually you want to observe as much as possible with your telescope, but your telescope is also developed to observe certain objects in mind. So for example, if you want to observe black holes, the only way we can do it is by looking at the X-rays on the accretion disk around those black holes. So that means your telescope needs to be, if you think about your frequency in literal wavelengths, you have to observe at millimeter wavelengths. So that means your surface accuracy of your telescope needs to be extremely good, but also you need to be above water vapor, because X-rays get dispersed in the atmosphere. So that's why there's only a few X-ray telescopes around the globe. And that's why they've been using the Event Horizon Telescope to observe the images of the black holes. But if we can put a telescope on the moon, especially not at the dark side of the moon, or the far side of the moon rather, then you have almost no light pollution if it's optical. And in radio, that's perfect, because you have no interference, because you are shielded from the moon, from other electromagnetic radiation from emanating from Earth. So yes, that is a great place to put a telescope. And then we also have telescopes in orbit around Earth. We have Hubble, we have Spitzer, we have Chandra, and now the James Webb as well. So those are better, but the ideal place would be to put a telescope on the moon. It just makes sense. It's going to cost a lot of money, but yes, it will be the best way to observe the universe. And especially going to the dark ages, as you said, Andreea, it would just give better resolution to study the dark ages and to see where dark matter comes in and what happened in the first couple of nanoseconds and milliseconds after the Big Bang happened.
Well, just for clarity for someone like myself and maybe a general public that might not know exactly what the dark ages, are we talking about a literal dark ages, or are we talking about a dark age of information, like lack of information that we have compared to what we have now?
Both. It's just because there's not much. So the way we collect information from the universe is primarily via light from stars. So if the stars are not born yet, there's no light coming, so we can't actually see it with normal optical telescopes. We can't see it any other telescopes we have, like for example X-rays, as Heystek was mentioning, or infrared or anything, because these are wavelengths which are emitted by stars in different stages of their evolution, or different types of stars. So if there's no stars there, you can't actually gather any information. But as I said, there's stuff there. You mentioned dark matter. Dark matter is present already. Unfortunately, dark matter doesn't emit or absorb any light, so we can't actually see directly, so we have to rely on indirect methods. So if dark matter interacts with some form of normal matter, and the normal matter bounces off some photons, for example, some radiation, then we can collect that radiation and kind of reconstruct what happened. Yes, but as I said, there's dark matter, but there's also gas. Hydrogen gas is present in the dark ages. It's just in between. Is not quite next to the big, not right at the Big Bang. So a bit after the Big Bang, when hydrogen already had time to form. So the universe had to expand and cool a bit for the protons and electrons to kind of get together and form a hydrogen atom. So that happens a while after the Big Bang, but that epoch is fairly long. So it's kind of a long period of time where it's just hydrogen gas and maybe a few stars here and there, but there's not enough light for us to collect with our telescopes. But the radio, so hydrogen has this unique property that when you have, there's a proton and electron, and you can bump well, the electron has a spin, so it can change the spin from up and down. And when it does that, eventually, not all the time, but once in a while, it changes its spin, and then it emits a light. And this light happens to be in radio waves. Now, this well, it's 21 centimeters, but that light could be redshifted if that hydrogen atom is very, very far away, and the light, it was emitted in radio, but by the time it comes to us, might be shifted into a redder part of the spectrum. So that means you start with 21 centimeters, but you stretch that wavelength to longer, maybe into hundreds of centimeters, meters, or so on. Now that's basically radio waves. There's a fairly large spectrum of radio waves, and as Heystek was mentioning, there's a relation between the wavelength of that you're trying to measure and the side of the dish. So the bigger the wavelength, the bigger the dish you have to construct to collect that wavelength. Otherwise, the wavelength will if you have a smaller dish and a bigger wavelength, the wavelength will just pass by and you will not be able to collect it. So basically, we need huge dishes to collect that light from the dark ages. And that comes into complications. So both on Earth and on the Moon, of course, the complications of constructing a big telescope on the Moon are many more than on Earth. On Earth, in principle, you could construct a big dish, but on the Moon, you have the added complications: how you transport that dish, how you assemble it, and so on, and how you correct for any problems that you might get. You can't correct it in real time, so you need astronauts to go there and fix the telescope. So that's an added complication. So that's why there's lots of ideas how to build these telescopes on the Moon. There's some groups in US actually, and I think they're also funded by NASA. And they're thinking to, one of the ideas is to put one of these big dishes in the bottom of a crater, in a moon crater, because it's fairly stable and you can just assemble. You can send some robots to assemble this big dish over there. And I think that Chinese are also on the chase of this, and they're already starting to assemble, but they're not. I think the idea is to construct, rather than having a big dish, you can put little antennas, and Heystek knows all about it. We have this technology on Earth, so it's called a radio array. So then you break this big dish into lots of hundreds, or like for example, the square kilometer array telescope is basically a telescope on a square kilometer area on the Earth, right? It's made of these little antennas. So that's actually better to put to construct something like that on the Moon, because you can send these little antennas, and then you can send your robots to assemble these antennas. Or you can even make these antennas on the Moon by, for example, 3D printing and so on. So there's lots of ideas.
Would it be would it be easier to have maybe a focus of technology to be able to construct little arrays that we could be able to launch at different maybe not, I wouldn't say launch it at the Moon, but have little specific points where it doesn't take up a huge focus of a particular area, but maybe, you could launch something at Venus, you could launch something at Mercury, much like we can launch a rover somewhere, just to enough where when it hits, it can set up and send a signal when it does hit. I mean, I know we don't have that technology maybe yet, but also I think that's something that could be developed in like a year or so if there was enough focus being put towards that. Heystek, you had a question?
Yes. Is there a possibility to do a screen share quickly?
A screen share? Yeah.
Yes.
Let me switch that over. There you go, partner.
Okay, cool. So I just want to share an image. So you should be able to see this image now. So this is what Andreea was talking about, the Dark Ages. So when you have your Big Bang, and here you have in 400,000 so here we have your recombination, your Dark Ages. So this is in billions, so 0.1 billion years. So here we have 4,000 years. You can see the Dark Ages is a biggish area, but if you determine it, and that is what she said, everything consists of the most abundant elements in the universe is helium and hydrogen. So that's where the mixture comes from, that creates. So here we can see the first stars being formed, first galaxies being formed. And that is just the timeline of the Big Bang.
Well,
but
if you go all the way back to the if you go all the way back to the beginning of that graph, you see where it's like light and blue and it kind of looks like water, or it looks like there's this whole area off to the left at the 0.1 all the way over to the 400,000. But right at that 400,000 mark, there's a whole bunch of like what looks like a bunch of noise going on. Is that one of the biggest disturbance we've had? And then over time, it's just excelled and created this evolution of galaxies in a sense. So was the time it's actually better now in a sense, or we're developing more now than we were way back in the beginning? So over a long experience of time, the Big Bang is actually all these years later has actually created and caused this development to happen. So let's say 2 billion years from now, depending on but stars die. So wouldn't you have to worry about the fact that there would be this a growth point where we're at the 13.8 billion and then we just start to see it slowly decline? Would there be a decline over time, or would it just keep expanding and increasing? I mean, we know space is expanding and increasing, but I mean, I don't know how much of our information on dark matter is hypothetical or is stuff we actually know. I'm not saying we don't know much about dark matter, but I'm also saying, like, I looked it up. There's people that have more ideas about how much you could sell it for compared to how much, there's time travel linked in there as well too. So I'm just wondering, I understand this is a very, very long time, so I cannot base like off this short little thing on my laptop screen. But what I'm saying is the point that we're at now, are we just going to keep seeing the galaxies expand farther and become this thing that we're still going to be learning and experiencing more, maybe new things a part of our galaxies or a part of the formation of space? Or are we slowly going to hit a peak point and then we're going to see a giant slowly start to decline? Now it's going to be maybe we're probably not even going to be around to experience it. I know we're not going to be around, but human species might not be around to be able to experience it. I'm just curious if there is this explosion, this creation over a long period of time, does that creation slowly start to dwindle out with the developing factor that stars also die out?
Yeah, if I can pitch in here, maybe Heystek could add more things. So that disturbance, as you call it, that is a very thin sheet, right, 400,000 years after the Big Bang. That's actually a very crucial point in the evolution of the universe, is what we call the recombination. Is before that everything was plasma, and matter and radiation was kind of like bundled up together, and because of that, the radiation was not able to escape. So it's basically like a big fog, a big haze, and you can't actually see anything. There is stuff going on, but unfortunately we can't probe it. So the first time we actually probe it is that at that threshold, 400,000 years after the Big Bang. And these were very important observations made by, for example, the Planck satellite and WMAP satellite in space, as Heystek was mentioning. And they saw this we call it the surface of last scattering, the first time when these photons were able to escape this plasma. And so the radiation is pretty smooth. There's basically all around has a constant temperature, but they're in this constant temperature, there's some tiny fluctuations up and down. So like 1 part in 100,000 variations in temperature. So these are these little dots that you see that blue and yellow dots, these polka dots are these tiny variations in temperature. And from the sizes, it's a lot of information that's encoded there. So from the sizes and shapes of these polka dots, you can actually infer how much dark matter is in the universe, the age of the universe, how much dark energy is it, how many baryons there are, whether the universe is flat or closed, and so on. And that ties into your other question: will the universe be able to expand forever, as we see already is expanding? Would that continue? That depends on how much matter there is in a universe, both normal matter and dark matter. If there's a lot of matter and exceeds in energy the other component of the universe, which you call dark energy, that means the universe will the gravity will win. So it's like a tug of war between gravity and this expanding energy, which we call the dark energy. If the gravity wins, the universe will recollapse at some point. But all the observations that we have right now, and they're pretty solid observations, seem to indicate that this dark energy overpowers gravity. So in the future, the universe will keep expanding and expanding. So if you're an astronomer in a few billion years from now, the sky would be very boring. You won't be able to see that many galaxies anymore. The stars will extinguish the fuel, the hydrogen, and you'll be left with black holes and dark matter. And eventually the black holes will also explode. So there'll be just information floating in the universe and so on. Yes.
Well, besides coming across one of the biggest light shows that probably the whole entire galaxy or space of whatever you want to say would be coming across with multiple black hole explosions. What about the hypothetical possibility when Milky Way does touch with Andromeda Galaxy, that causing another full-on explosion, which doesn't just completely turn off all the lights, but completely makes a whole nother big bang or multiple big bangs? I mean, the interesting thing where I started getting, and if you brought this point up to me when we talked about the multiverse for a brief amount of time, and I actually mentioned this with Heystek as well too. The possibility of being able to, when we see that graph, when you see from the 400,000s where we are now, to be able to, if we're getting to this point where we can understand dark matter a little bit more, to be able to reverse it in a sense, not necessarily create time travel, but also be able to figure out what particles were also invented in the beginning when you see all that haze or all that fog happening in there. Because I have to think, much like dark matter is like a kind of a creation of, or like this kind of like booster, I would say, of the creation of a lot of things, I start going, well, also not just dark matter, but what else was incorporated when that big bang did happen has to be a factor in its evolution stages as well too. That's all the gases that were included, or were those created later? Because I mean, the weird thing about when I was looking up a little bit more about dark matter is that they were saying that necessarily it has enough energy that it could actually change the particles of our DNA. It could change. That's where people say like superpowers and stuff like that. Now, I don't know if that's real, what I'm coming across, or if that's just some crazy person writing a space article or something like that. But it has me thinking a little bit more where if we start understanding the fabric of our own DNA, and if we can take the basis of what we can study, the things that I can look at right now and I can physically touch, then we can examine that into a bigger proportion on the things that we can't necessarily see or we can't necessarily focus. And I start wondering, and I know a lot of it's kind of hypothetical what I'm talking about, but it just has me thinking a little bit more, and it has me kind of understanding why there's ideas about wormholes and there's ideas of this. It kind of links together with time travel in a sense, at least for me. I don't know if I'm coming across that or reading it right. I said a lot.
Heystek, do you want to pitch in? There's a lot of questions there.
So yes, the first thing I'm going to pitch in is just backtrack one step. It's like I'm just backtrack one step. So one thing is before we touch on these topics, bit on the instrumentation, like Andreea said. So when we observe the universe, we talk about the electromagnetic spectrum. The electromagnetic electromagnetic spectrum goes from low frequencies to very high frequencies. And in that range is our normal visible light. So I like the analogy of using you can think about the keys on a piano. So where your visible light you see, it represents one of the keys on the piano, and the rest of the keys are still part of electromagnetic spectrum that can be observed. But frequency can be converted into wavelength. They are inversely proportional. So the higher the frequency, the lower the shorter the wavelength, and the other way around. So if you ever think about how your microwave works, your microwaves is literally microwaves that's heating up your food, causing them to vibrate. But if you look through your microwave, you'll see on the door, you can see through the door, but you can see there's a little mesh on that door. So what that actually means is the literal microwaves that's created, the wavelength or the literal size of the wave is bigger than the size of one of those holes in a grid in front of your microwave. So when the microwave hits the lid, it sees it as a solid surface because it cannot penetrate your grid. The same thing you think about is a basketball court and you have a chain link fence around it. If you throw the ball against a chain link fence, it will just bounce off because it basically sees it as a solid surface. The same thing happens with your microwave. And then when you observe certain objects in space, the material you use to observe is important. So if you want to observe, for example, X-rays, that means your wavelength is millimeters in size. So that means you need a solid surface. So that's why you do certain observations. That's why it's important. So that's why I said previously, you can build one giant telescope, or you can build smaller telescopes and add their surface area, and that basically creates one big telescope. So now going forward to where we are now, we need better ways to observe. And for example, dark matter. We need to know what causes dark matter, how dark matter sits in the universe. We need to find direct ways to measure and influence dark matter. And coming now back to your point on what would happen if the Milky Way and the Andromeda Galaxy collides. So we can actually see galaxy mergers happening during our lifetime and will happen in the future. So what will happen is the chances are very slim if the galaxies passes into one another that physical stars will hit one another. But the nucleus of those galaxies, where your supermassive black holes is, they will merge and form an even bigger black hole, and then the structure of the galaxy will differ, and you will create an entire new galaxy on their own. Take, for example, the Milky Way galaxy. We have two smaller galaxies orbiting the Milky Way called the Magellantic Clouds. So we have the large Magellantic Cloud and the small Magellantic Cloud. And the Milky Way galaxy is actually cannibalizing those two galaxies, tearing off pieces of their matter and stars into our own galaxy. And that is what's happening. And also thinking about the Big Bang. So like Andreea said, what will happen? Is the dark matter, dark energy more than gravity, or will gravity win? So a nice analogy I also always tell my students, you can think about the expanding of the universe as a balloon. And you can make a Koki pen or permanent marker and make little dots on your balloon. And as it's expanding, you can just blow up your balloon. The balloon will get bigger, 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 and bigger, and all those dots will drift further and further and further and further apart from one another.
Okay. Andreea, did you have anything you wanted to add on to that? Because I'm gonna end up tossing out a question out of left field, and I know it's gonna throw us off.
Yes, I know you're interested in time travel by the look of it. So as Heystek was saying, we actually see galaxy merging a lot of time, and they don't produce anything other than bigger galaxies and bigger black holes. And that in itself is not enough to create a Big Bang. A Big Bang is still a singularity like a black hole, but it's a different type of singularity. And we know how to create how black holes form. So you need basically a star, a massive star, to form a black hole after it explodes in a supernova or something. So that happens a lot in the universe, but we don't actually know how the Big Bang came to be and what was before the Bang. So it's a different type of physics that you need to have. So it's not like we actually see other little big bangs happening. Now, I'm not answering your question 100% honestly, because we don't actually know what's inside of black hole, right? So once something goes into a black hole, we kind of lose any type of information. Doesn't send us back any information, say, hey, I'm in a black hole, hey, I'm in a different universe or anything, right? So that's still a possibility, that, you know, but as far as we know, we have absolutely no information coming from a black hole. Wormholes are slightly different. So actually there's two different things. You could, in principle, well, theoretically, so not everything that's theoretically imagined, it also could happen in reality. But let's go into the realm of imagination. You can have a black hole, and on the other side, you can have, again, another theoretical construction, which, and in this time has not been observed, like a white hole, right? Which is exactly the opposite of a black hole. We do observe black holes, but we never observed a white hole. A white hole will be exactly the opposite of a black hole. The matter will come out of a black hole. So in principle, you could create a tunnel from a black hole to a white hole, but then again, we haven't seen a white hole, and even that tunnel between those two singularities, you would need to kind of keep it open, and there's no way at the moment to kind of create that exotic matter or some type of energy that would keep the bridge between a black hole and white hole. So people have thought about all these things, but they have not been observed. Wormholes, again, there are some theoretical constructions. Wormholes are just like tears in the fabric of space-time. So if you take the space-time and you can just fold it and create like two holes that you can connect it through a bridge again, you don't actually tear the space-time, you just fold it, so then you can connect one part of the space with another. Then you, in principle, you can create a wormhole. Again, they have not been observed. We don't actually know if they exist or not.
Well, my interest in time travel isn't necessarily like Back to the Future style time travel. It's more on I guess, in a more of a resource type idea of time travel, which is the idea of bringing back something to a previous point based on the information that was at that point. Mostly when I start learning about comet impacts or asteroid impacts, it comes at a time scale like dinosaurs and all these different sediment layers on top of each other. And I start wondering, if we can record it through that way, there's got to be a way to record it through something that we don't really know a whole lot about yet. Now, it is a very, very hypothetical or kind of an imaginary scenario type deal, but I start wondering, I mean, just with not necessarily on the idea of time travel, but if we're talking about altering cells, for instance. Now, I know this is on like a long scale thing, but when we talk about, like, when Heystek pulled up the graph before and showed this point where there was what you would call plasma in this area where it seems like there's a lot of fog. And it kind of links into a lot of my questions with UAPs, where we start talking about like these things that people are seeing UFOs. Are they UFOs, or are you seeing a form of plasma, much like a mirage has an effect when it's too hot outside? You end up seeing water that's officially not there. And I start wondering, with plasma, are these remnants of something that we really haven't recorded, or it might have been recorded for a while, but it's just things like little particles that are somehow getting hooked into our atmosphere? I mean, we know we have different measuring devices. We have observatories that can measure things that human eyes can't see. We have devices that can measure things that we can't see. It seems like they don't even exist by our human eyes because we can't pick them up, but a device can pick it up. So I start wondering, there's probably a lot of information that we just don't know because we don't have devices to pick these things up yet. So when something does come across a rare occurrence or phenomena, I would say, of what these people call UAPs, is this necessarily something that was way, 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 way before that somehow has leaked its way in? And it starts having me asking questions of like, could it be a possibility that it's all around us? I mean, there are more things that are probably way, way older that we haven't been able to pick up or trace yet, but it's at such a faded low bar compared to the measurements that we're pulling out of like graphs like Heystek has, or these ideas of what they were when it first started. I mean, after all those billions and billions of years, I mean, it's kind of like you age. You're young and spry, and then next thing you know, you're you're older, you don't have the same amount of energy. And I start wondering if we talk about this matter of like, we're all energy or something of this sort. If it's this fading frequency, there's probably a lot of these particles or these things like necessarily that weren't as strong as they were in the very, very beginning when the Big Bang happened, that have faded to such a point or expanded out in such a point, much like the galaxy is expanding, that's just causing it to spread all over the place. And we might be having small, minor, very fragmented interactions with these things. I might just be rambling at this point, but I'm very like, I'm not interested in space, or I'm not interested in the idea of time travel as a literal time travel of going back to like 1950 or something like that. I'm interested in the aspect of what information we can pull out if we were able to somehow retrieve data from a pre-point where it could actually just cause this whole other timeline where we have a whole new boost of information.
So on a sci-fi level, jumping into this, a good example is the movie Arrival, where the aliens comes to Earth and you need to have this linguistics professor speaking about or trying to find a new way to communicate. And in that movie is we as humans perceive time as linear. So if it's time's always moving forward, so the past, the present is there, and we get the future, and there's no other way to perceive time. But in that movie, the aliens doesn't perceive time as linear, and they taught to humans a way to perceive time as non-linear, which is an interesting topic. But on a more practical side of it, if we look and observe objects in the universe, we're actually looking back in time. So, for example, our Milky Way galaxy is 75,000 light years across. So that means the light we are seeing from the other side of our Milky Way galaxy happened 75,000 light years or 75,000 years ago. So we are seeing the light as it hits us 75,000 years ago. So the same thing, the closest star to us, Alpha Centauri. We are seeing that light as the star was 4.2 years ago. So if that star would something, let's say, for example, we have something like the Death Star and it blew up that star, it would take us 4.2 years before we realize that something has happened to that star. So the further we look, the further objects we observe, the further we are looking back in time. So that is, we call that the look back time. So that is one way we observe the universe. We see it as it was. So say, for example, if we look at the Andromeda galaxy, and say, for example, there were dinosaurs on one of the planets we could observe, and we would be observing one of the planets in the Andromeda galaxy. If they had dinosaurs, we would see dinosaurs walking around because we would see the galaxy as they were millions of years ago and not as it is today. And this as speaking back to the sci-fi, speaking about sci-fi, time travel would be cool. It would be cool looking back in the past and seeing what happened. That opens the paradox of if you change something, will it create a new timeline? How will it influence the present? Will it create a parallel timeline stream? A good example of that is the Marvel universe with Doctor Strange. And also, I know in the Star Trek universe, they played around a little bit with this as well. We have your main universe, the main timeline, you have the mirror universe and the Kelvin universe. And that is interesting. And that brings me to a quote that the physicist Michio Kaku has said. He's a futurist as well. And he said he believes time travel is only an engineering problem now.
Yeah, I just wanted to add a few things you mentioned about things changing our DNA or our cells. And there's something in there. I mean, obviously, we know about cosmic rays. Cosmic rays are like very energetic particles that are coming from supernovae or from the sun, for example. And we are, in fact, bombarded by this highly energetic particles all the time. And we actually survive we have on Earth, because we have this protective layer, our atmosphere, and the magnetic field, which basically deflects a lot of this high energetic cosmic rays. If we had no magnetic field, like for example on Mars, we would have a much higher level of radiation. And as you know, radiation is very damaging to human cells and tissue. And that's why, for example, astronauts, when they go in space, they have to be wearing all these suits and not go for a very long time because there's high levels of radiation. And we are embedded in the universe, and the universe could be very violent and very energetic, and is not a very pleasant place to be without protection. So there's lots of things that interfere with our human tissue, and also there could be damaging, but it could also be good, because there's, for example, evolution on Earth. You need you need some changes from generation to generation in order to kind of spur that evolution. And for example, cosmic ray could damage, in quote unquote, DNA. We lost Heystek.
His power in Africa.
Right.
Yeah.
So a very powerful particle could damage your DNA, or not necessarily could be a good change that would spur a new level of evolution. So it works in both ways, both for the bad and for the good. Now, in terms of dark matter, unfortunately, it doesn't emit much light and absorb light, and that's the reason we cannot detect it. If the dark matter would be so energetic that it would be good, powerful enough to destroy our human tissue, we would have observed it by now, right? The problem is that it doesn't emit, or if it emits any light, it's very weak. That's why we've been scratching our heads for about 90 years to detect dark matter. Now, I don't know enough about the ball lightning and earthy phenomena, but what they emit any radiation or no, I think to my mind, I would imagine they're very confined phenomena. And I'm not sure if it would be safe to walk into a ball, plasma ball, but if you're a fair distance from it, I would imagine that would be very damaging to our human tissue.
Well, ball lightning kills people. There's plenty of occurrence of that. That's why people are so wondering how people can see like this spaceship, or they see multiple different things. And a lot of these, from what I talked with Massimo Teodorani, who studies plasma in a sense, and he talks about how you can see different variations of it depending on which type of plasma that you're looking at. And I just bring it up because I don't necessarily think that it's alien tech. It might be, I don't know. But at the same time, I think it's probably more plausible to go with the idea that it's kind of like a mirage, and what we're seeing with this light phenomena is probably something like we see with just a mirage, of water in a road that's not necessarily there just because it's too hot or something like that. But if we take it to the example of altering cells, so the amount of questions I ask, they might seem sporadic or random or really kind of like different. It's only because the combination of people that I've talked to in specific areas that have given me a certain amount of information or a certain amount of ideas where I start trying to plot them together and pinpoint them in a sense. So when we go to the idea of dark matter manipulating cells, the reason why I ask that question is because whenever I ask someone about like when's the end of the galaxy, whenever Andromeda or Milky Way is going to collide into each other, people say humans are not going to be around. And I'm like, well, what idea of humans are we talking about? And the reason why that I say that is if there's a way that you can figure out that dark matter does manipulate cells, I mean, after a long period of time, I mean, are there ideas of sending a person through a black hole and seeing what happens? Would they just rip apart? Would they just disappear? We wouldn't be able to trace them, right? So then I start wondering, if a white hole is the complete opposite of that black hole, what would that do? Would it still just disappear? If the black hole implodes on itself or causes a person to implode on themselves, would a white hole cause the person to expand out? Where I start wondering, if there's ideas like, if I look up dark matter, what would it do to a person? People can say hypothetically create superpowers or alter a cells in a person. I start wondering, when we say that humans won't be around to experience something, are we talking about the human forms that we're in right now? And I know that gets a little bit crazy, a little bit sci-fi out there, but I start wondering, to think that in the next 1,000 years or 2,000 years, we're still going to be at this capacity of this physical form, and we might not just take a different form. I don't know. I know it sounds very Futurama-y, but I mean, you can take it with a simple example, which is the evolutionary changes between generations. My grandfather is not like me at all, body wise. You know, the alpha males that smoke a cigarette riding a chopper or something like that. That's not today. There's a different form of what we would call an alpha male. And that's necessarily from the idea of what I would say prosperity, even though people can say, well, there's issues with war and all this stuff going on now. Yes, but when it comes to prosperity, I specifically mean on the prospect of resources. And as much as we can complain about a price of gas or something like that, the prosperity for food in most places is better than it was 50, 100 years ago. So the capacity for evolutionary change starts to set in when you don't have to worry about going out and hunting as much, or you don't need to worry about these certain things. Where I start going, if it's a simple explanation like that to explain that evolutionary change in just a few generations, what's the thing later down the line when you discover that something can manipulate cells? And then cutting off that question, I'm also going to ask the question, is there a specific point that we've been able to focus out where there was the prime example of the Big Bang? Like when I mean that is in the galaxy, like you can notice when a bomb goes off, there's the explosion crater and then everything that gets developed around it. So I start wondering, how far are we away from that plot point of where, if we do understand where that Big Bang initially had this explosion, and then how far from that explosion or that plot point are we? Is it like the sun? We know we're a certain amount of distance from the sun to sustain this form of life, where I start wondering, can you be able to graph from that plot point of the Big Bang what developed around it? Is there other things closer that are more violent, more radical? Are there things farther away where you start to see the expansion of growth, the materials, the gases in the atmosphere? I mean, I don't know. I'm thinking really out there because I'm very interested in the topic.
Yes. So the dark matter, first of all, dark matter, as we haven't seen it, but we think there's all around us. So if this dark matter is some form of particle, some small particles, we should be floating in the sea of dark matter. So as we speak, for example, we believe there's like trillions and trillions of dark matter particles going through you and me without actually interacting at all. Okay, now it could be that once in a blue moon, one dark matter particle interacts with a cell, and is actually that some of a category of experiments on Earth are built around that idea that once in a blue moon, a dark matter particle would bump into an atom and will, for example, either shake the atom a little bit, jiggle a little bit, and then we can actually measure that vibration. Or you could bump out an electron and could collect the electric current. But for example, you would expect one such interaction once a year or something, or I don't know exactly the rate, but very, very right. And so they build this huge barrels filled with like heavy liquid in order to kind of slow down these dark matter particles and make them interact. So I don't think as far as we know, dark matter is not able to interact with us and make any changes. And if there is, the changes are minute compared with all the other interactions our body suffer with, like cosmic rays and light from, for example, if you mentioned that what happened in the past, in the beginning, right? In the past, the universe was much more violent. There was much more star formation, and there were many more supernovae going on. Now, we've been very fortunate that we haven't actually been living next to a star that was exploding. If a star would explode as a supernova nearby, the whole civilization would die because we cannot, the level of radiation would be so high that would not sustain life on Earth right? So it will wipe out the life on Earth. So if for example, if you look at the Milky Way as a big galaxy, there's regions in the Milky Way which have much more star formation, like for example in the center of the galaxy. There's also a black hole there. There's lots of energetic events going. So the closer you get to the center of the Milky Way, the more there's less likelihood of having planets with life. There's a certain habitable zone, as we call it, around, like a ring around the Milky Way, not too close to the center, and also not too far away from the center of the Milky Way, because you need some star formation to kind of enrich the environment with metals and with chemical elements, the organic elements that make life. Now, looking back into the early universe, there's lots of supernovae going on, so that the things if you happen to be on a planet around a very big star that would blow up as a supernova, then again the life would be extinguished. Now, in terms of our future, now obviously there's evolution going on, and we are not at the end of the evolution. Our future generations will be quite different from us, most likely, and we are living at the very interesting intersection where we start to kind of morph with our with machines. We're already kind of glued into our phones and laptops and so on, so we can't actually live without them. So you can actually see where the future generations might go to. It's not clear that it will go that way, but it's a possibility that everything will be much more connected with machines. People also talk about the AI and different developments. So it's possible, and actually it's quite good. And I think Avi Loeb, which I know you had on your show, he also advocates sending AI in space, again, because the space is so inhospitable to humans. It's much better to send machines, and we already do this with the whole Mars exploration is with robots, right? And we have lots of rovers on the Mars, and we send all kinds of machines on the moon, and all our telescopes, we can call them as our extensions of our bodies, right? You don't actually need to go to space. You can just send a telescope and observe the universe, or explore a planet, so on. So yes, our future generations would be possibly very different from us. Now, we won't turn into dark matter, but we'll probably find a way of kind of, I don't know. I don't want to speculate, but dark matter is not very good. We don't actually know what it is, but the dark matter cannot actually form human forms, because the strength of interaction between dark matter particles is very weak. So our bodies are held together by chemical bonds, which are very strong. Now, people also talk about a whole dark matter spectrum. So dark matter, instead of being a single particle, could be many particles of different, all dark, right? As we see, for example, on Earth, we have protons and neutrons and electrons. We have a whole zoo of particles, right, on Earth. And why do we have so many? And we don't actually know, but that's what it is. Reality is very diverse in terms of particles that we're made of. And the same could be said about dark matter. Dark matter could be a whole spectrum of dark matter particles. And I should mention that since sometimes we veer into this sci-fi, we could also veer into fiction. And I know there's a nice book by Philip Pullman, and he actually envisaged a form of conscience made of dark matter in one of his books. It's actually quite interesting.
Well, I bring up this point where, is there areas of space where there are no stars, and would you say that that place is just lacking star formation, or would you say that place is just filled with too much dark matter? Like, if you can't see any light, like there's just pitch black, and you just look like you're floating all by yourself if you were out there, then if that's a possibility, wouldn't there be a possibility of the opposite as well too? I think you see it in cartoons when they just have the cartoon and then it's an all white background. I mean, would there be a possibility for that too? And if we look at the spot where there's just nothing but blackness, there's no star formation, is that 100% true? Or is that a factor of maybe that there's so many particles so thick that we just can't see the stars that are going? Like, it's like being in a fog. sometimes you can't see your hand in front of your face if it's really, really thick fog. I mean, is that dark matter that's filled up in that black spot of the galaxy?
Dark matter likes to clump because it just feels the force of gravity. So that by itself will just form dark galaxies. We call them dark matter halos. And our galaxy is embedded into this huge dark matter halo. But there are some, as you go to smaller and smaller galaxies, some as Heystek mentioned, dwarf galaxies, like, for example, Large Magellanic Cloud and Small Magellanic Cloud. These are like tiny galaxies. But if you go even smaller than that, then you, in the regime of dwarf galaxies, the dwarf galaxies have very little stars and a lot of dark matter. They're actually dark matter dominated. So if you sum up all the matter there is in there, 90% is dark matter and 10% could be stars. And you could also envisage that there's these dark matter halos that leave just by themselves with no star formation at all, just because you can't actually, for some reason or another, you can't actually collect gas into these dark matter halos. I'm not sure if it answers your question, but we know actually of systems, but these are systems on the scale of galaxies, not individual particles, which are made of just of dark matter.
Heystek, do you got anything to add?
Yes. So if you think about the universe and space, most people think about space as being a vacuum, that there is nothing, but that is actually a common misconception. So you will still find particles out in space. It's not really a vacuum, but the particle density is so low that you can basically think of it as zero, but yes, there are still particles. And thinking about, that you said, some form of radiation or particles that can change our evolution. That is happening around us. A great example is the Chernobyl nuclear disaster. The radiation has caused generations of kids being born and generations after to form some form of cancer. That is your cells misbehaving due to radiation. Yes, we have a lot of radiation here on Earth that can change cells, but thinking about it, the good example I always use with my students, your microwave and your cell phone emits the exact same radiation. The only one thing is the microwave is so intense, or the radiation is so intense that it can heat up your food. But with your cell phone, the radiation is at such a low intensity that you can basically leave it out. But on the biology side, I know a lot of people stir up a lot of debates about it, is technology called Crispr, where you can identify certain genes and you can actually change it. So if you are expecting a baby at a certain point of the development phase, you can intercept it, you can use CRISPR, and you can actually change DNA on your baby. So then you can actually pick what color of hair should be, what the eye color should be, what a bit of a physical attribute should be. So yes, that technology does exist. And speaking of space, where you're talking about, are there no stars? Are there a lot more stars? Yes, there are certain places where stars are much denser, clumped together. Same with galaxies. Certain places, galaxies are more clumped, tied together, other places not. But it all depends on what we're observing. So some region in space, you can look at it through an optical telescope, and it will see there's nothing there because there are particles blocking your way that you can't see through it. But if you use a different means, such as a radio telescope, and you look at radio waves, microwaves, X-rays, then you can see through that cloud and see what is behind it. But just to throw a little bit of a spanner in the works, I'd like to share my screen again. Can you see my screen?
Yes, the Drake equation.
Yes, do you know the Drake equation?
Nope. That's why I said it out loud. Did it make me seem like I knew it?
Yes. So this is something I've discussed with my students recently. So the Drake equation determines what are the chances that there are other intelligent civilizations in the universe around us. So this was formed by astronomer Dr. Frank Drake. So he was in the Green Bank Observatory in the US. Even if you have a chance to visit the Green Bank Observatory, please do so. It's one of the best science institutes in the world. And there's a lounge in the observatory called the Drake Lounge, named after Frank Drake. But this equation predicts how much intelligent life might be in the universe. So we have n, so we want to calculate the variable n. So R is the average star formation rate in a galaxy. So you calculate this per galaxy. So R is how many stars are formed in a galaxy in a certain time, usually a year. Then you have FP, from that stars that develop in that galaxy, how many of them have planets orbiting them? And then from that planets orbiting them, those stars, how many of those planets are in the habitable zone? Or I like to call it the Goldilocks zone, because it's not too warm, not too cold, it's just right. And then from those planets, which of those planets actually develop life? And then from those planets that has developed life, which of them has developed intelligent life? And then from those planets that have intelligent life, which of them have the capability to develop communication system or communicating with us? And then what is the average lifespan of that civilization? So that's taking account, will their star go supernova? Will something happen to them? And then you can get an estimation of how many civilizations there are in the galaxy. So thinking about it is, if you look at the worst possible approximation, then we humans are the only life in the universe. But if you look at the optimistic variables you plug in, then there should be 15,600,000 intelligent communicating species in our own galaxy. And that is just something to think about.
Well, much like I talked about with a friend of mine who studies impact craters, I mentioned the fact that this Earth, this life, everything that we know around us could be probably the worst possible scenario out of the Big Bang. I know that's not necessarily thinking positively, but I mean, in a sense, to me, that's a little hopeful to think that there's other possibilities out there. I'm not saying that they exist the same timeline this is, but if you look at like the idea of life forming, and we're basing it off the Drake equation. The way I kind of think of this is that the fact that not only just because Andreea is focused in with dark matter and this concept as well either, these are not why my questions are being asked. My questions are being asked because the idea of what we know about dark matter leaves the possibilities kind of endless in a scenario. And where I bring up the point of, if dark matter can't affect our cells that are in our body, this chemical compound that we have, but for how long? I mean, if we talk about, like, if I use the alien experience, for instance, or if I use the idea of people seeing more than that, I don't know what that is, but if we're talking about light plasma, there wasn't this many occurrences or reports about it even 50, 100 years ago. Where I start being, is this a factor of radiation? Is there just particles that are being trapped into our atmosphere that aren't, like, we're having solar flares happen a lot. Like, it just happened like 5, 6 months ago in Arizona. They were fluctuating of power. They couldn't do this. So I start going, nobody talks about, like, what, 2 weeks later, they're like, everything's back to normal. Hang on a second. Like, what's that? There's something there that we're like, not, maybe the general public doesn't see, but there's a scientist that's focused on it, where there's no way 100% of what entered in 100% goes out. That just doesn't happen. Get a bottle of water, you have to leave it upside down for a couple of days and let every single drop come out when you clean it out or something. That's what I'm saying, is this phasing point. If we look at the time scale, like the probability of billions of years, I mean, what's the probability or the idea that in a couple hundred years, the eventual radiation or whatever that our planet consumes, how much of that is leaking out at a rate that it's being consumed in? Where I start wondering, is it that crazy to think, or maybe mad scientist of me, let me just add white hair and spike it up like Einstein or something. But I mean, the possibility that your chemical compound or these little bits maybe can't be measured in such an extreme portion, but over time could be something that could eventually interact with dark matter. If we bring up the blue moon scenario, where we're able to read one of these weird runoffs from a dark matter particle that's a random occurrence, what's to say that blue moon experience doesn't become something more normal, like a full moon experience, where we're coming across more readings of these types of things? And then I kind of link that in with the alien idea, which is what people are seeing necessarily might not be the idea of aliens. It might just be something that we're experiencing more frequent because of the factor of the time and these small shifts that are happening that we're necessarily not, as a human being, reading, but probably another device could measure it. I mean, that's what's interesting about this whole thing, is like, even with dark matter, I mean, as much as we do know about it, and then compared to what we don't know about it, I mean, the possibilities are endless of scenarios or possibilities that could happen, which to me is just fascinating. I mean, I'm an outside observer. I'm not involved in this, looking in on it. So I have these types of questions where to you guys, it might seem like that sounds, no, it's not possible.
I think these are good questions. One thing to bear in mind is that dark matter has an effect, obviously, but on much larger scale. So won't actually, I don't think that it will have an effect on the scales of the Earth. But if you think of the scales even of the solar system, might have an effect there. And the main force that which we know that the dark matter responds to is the force of gravity. So gravity is actually a very weak force. We have 4 fundamental forces in the universe. Gravity is one of them. It's much weaker by factors of 40 times weaker than, for example, electromagnetic force, right? So having said that, if you go on a much larger scale, like the scale of the galaxy, for example, there's a lot of dark matter, there's a lot of matter, and the force of gravity becomes dominant. So on a scale of a galaxy, is the gravity we worry about, not the electromagnetic forces, right? It's the other way around. So that's when we actually have to take dark matter into account. And obviously, as you said, it has a cumulative effect, because the dark matter, the force of gravity is always attractive. So you only add layers and layers of dark matter. Dark matter does not escape. So once it comes into a galaxy, it just kind of piles up and forms a bigger and bigger dark matter halo, as we call it. Now, somewhere in between, I remember, you might find it interesting. There was actually I won't call it a theory, but a speculation, an interesting idea put forward by Lisa Randall. She actually wrote a book on it, and kind of connecting human evolution or evolution on Earth with dark matter. And she, if I remember correctly, was that the solar system is flat and right, and then the dark matter would, if it piles up at the edge of the solar system there, it might affect the the solar system is embedded into a disk, which also, like the disk of the galaxy, could also have another disk of dark matter. So you can see a lot of inhomogeneous distribution of dark matter around us. And she was hypothesizing that some of this dark matter could affect the orbits of asteroids, and one of this, by just disturbing a bit the outer edges of the solar system would throw in some of these things onto Earth, and this is how they for example, they affected they killed the dinosaurs, right? So the root cause, she was saying, was dark matter. Now, I don't think that idea caught onto the wider community, but it was an interesting thing, and it kind of shifts your perspective on things. Just kind of take dark matter into account on scales that you weren't able to think before. And whether that's true or not, we don't know. But actually, it's interesting that the dark matter could affect human evolution in some way, maybe in an indirect way, and not at the level of cells, and, as I said, at the level of what's happening on Earth, right?
Have we ever been able to record on one of these halos where all this dark matter can get composited outside on this halo ring? On the inside, what happens if something caused an implosion and caused everything to kind of be sucked in, like a black hole would just eventually suck up everything, like every star, whatever you want to say? Would this halo, if you had something implode on itself and then close and be over with, this halo ended up clashing in, or all the outside pieces clashed in, and would that create something?
It's just like matter, dark matter is just like matter. It's basically, we don't actually collapse them into it's you need a very high density of dark matter, and we don't know whether the center of dark matter halos are so high density. All indications are that there's a certain plateau of the dark matter density at the center. So you'll never get these dark matter singularities or anything, and you can't form black holes from the dark matter. So actually, the only black holes that we've seen are made from normal matter.
Well, what is there a chance of spontaneous black holes, or ones that are these just ones we just haven't been able to detect before they occur?
So yes, I lost connection for a moment. So I think one thing you asked that I didn't know if it's been answered. Have we talked about the central point of where the Big Bang might occur, or how to determine that point?
Yeah.
We haven't talked about it.
We haven't talked about it yet.
No, so that's one thing I made note of that we haven't talked about yet. So the one thing is, if we look, we cannot determine where the Big Bang happens. So if we look in every direction out there, the universe is expanding equally in every direction. So the best way you can think about it is the beginning of the Big Bang is everywhere. So everywhere is the center of the Big Bang where it happened. Then coming now to your black hole, how a normal black hole forms with normal matter. So the best, or usually is at a black hole forms at the end of the life of a giant star. So we like to measure things. So if we say something is one solar mass, that is basically the mass of our sun. So I know in school you have learned that you cannot divide by 0, then your calculator doesn't know what to do. But what actually happens is when a black hole forms, if you have a star that's between 1.3 and 3 solar masses, that means 1.3 the times of our sun and 3 times the mass of our sun, that star will form at the end of its life cycle a neutron star. So that means it is compact and very, very, very dense. So you have all those weights of the original star. It's compacted in a very small region, and that creates objects such as neutron stars or pulsars. But if you have a star that is above 3 solar masses, at the end of its life cycle, when it goes supernova, that means its outer layers is blown into space in a big explosion called a supernova. But the core will contract onto one another and implode, which actually happens there. If you do the math, that is where you divide by 0. That is called the Chandrasekhar limit, where everything is pushed down together, and that is pushed down into a small singularity, and that becomes the black hole. So you only get a black hole if a star dies, or a star that's more than 3 solar masses, so 3 times the mass of our sun, and at the end of its life cycle, it will become a black hole. And that is how normal matter will become a black hole. And then you also get black holes in the formation of galaxies. The majority of, or basically all galaxies we observe, has some sort of a supermassive black hole in the center that keeps the galaxy together. So as we have our own sun, and we have a planets orbiting around the sun's gravity keeps everything in check and in place. We need the same mechanism on a bigger scale, such as in a galaxy. So in a galaxy, that central mass is a black hole. And that forms part of a branch of astronomy called active galactic nuclei, or AGNs. And some of these cores or black holes in galaxies may be active, may be pulling in materials. Some may be dormant and not pulling in anything at all. But that is the process how normal matter will form. But Andreea, you can correct me if I'm wrong, but in the formation of galaxies, that supermassive black hole that formed in the middle of a galaxy, that has a bit of a different mechanism to it. And if I'm correct, that is where the halo of dark matter comes in.
Yeah, yes, you're right. I mean, I think the supermassive black holes at the center of the galaxies, they are quite different from the little black holes from individual stars. But having said that, they have to grow from a seed, right? So it's unclear at the moment how this supermassive black holes came to be so big. And we also discovered them very early on in the universe, like when the universe was very young. So that's another problem. How do you form these gigantic supermassive black holes so early. And rather than having one star collapsing, you could have like a giant gas cloud collapsing and forming that supermassive, just to give it a bit of a kick to start the process. And obviously, the bigger the black hole is, the more mass would accumulate, and the faster it will grow in time. And as you mentioned, you can spur the growth of black holes by just merging galaxies. So the Milky Way has a supermassive black hole at the center. Andromeda has one. When these two galaxies will merge in about 4 or 5 billion years from now, these two black holes eventually will find each other and will spiral in and make a bigger black hole.
Well, it was what I was mentioning with the halo ring. Now, I don't look at dark matter as a composite to make material or has the ability to make material. I kind of look at it like an inactive compound, I would say, but what can trigger that can make that thing active? And I start wondering, if we talk about a star dying and it causing a black hole, are there these rings, these dark matter rings around, let's say, one of these stars that creates a black hole, causing all these particles to form and this halo going from an actual halo compiling into each other? Would that cause a creation in something? Would that cause a disturbance in something? I don't understand. Maybe my knowledge on what, like, are we able to measure these types of explosion or these types of implosions that happen in space when a star dies or when something forms? Are we able to measure that on any scale?
Yeah, I don't think there's much dark matter. I mean, dark matter is a lot of it, but it's dispersed over, so it doesn't have the density. For example, in your room, right? That your body is much more denser than the dark matter is on the scale of a room, right? So it's the
I've
same
lost
thing on
5 pounds. What are you talking about?
the same with the star, right? The star, obviously there's dark matter particles around the star, but they don't actually add much to there's not enough density around the star to change the composition of the star or any nuclear fusion or processes that happen in the star. It only becomes important when you go on the scale of galaxies, and then you have less and less stars and gas, but more and more dark matter. But let me turn things around and ask the question, in the universe, most of the matter is dark matter. As I said, like 85% is dark matter and 25% is 85% and 15% is normal matter, right? Why would the dark matter care about us, normal matter, right? It's why would they, just turn things around, right? The most of the universe is dark matter. It's not normal matter. We are the exception. It's not dark matter is the norm. And same with the dark energy. If you go to this dark energy, that is much more dark energy than dark matter, right? So most of the universe is this form of two mysterious forms of either matter or energy, which have nothing to do with us.
So I have read a interesting hypothesis. Like you said, we are the exception to that rule. But I've read an interesting hypothesis which said, you can correct me on this, that dark matter is perhaps normal matter in a different universe that is interacting with our universe, the same way if we think about the multiverse. So it's just an interesting hypothesis that I read, that dark matter is normal matter in that universe interacting with our universe.
We can't talk about the multiverse unless we're gonna go into a whole topic of me asking about a future self or another possibility of me in there. But you can answer his question. But I wanted to bring up the point you mentioned about dark matter. Why would it care about us? And I go, well, the same reason water doesn't care about a fish. Eventually, to a point, you fill that whatever base that water is, let's say a pond, with too many fish. Maybe the water doesn't necessarily notice, but obviously the environment has changed. Where I start bringing up the question, maybe dark matter doesn't care about us because there's not a composite. There's a lot of empty space that literal empty space out there. So it's not like we're taking up large portions of it, but I bring up the fact of like small little compounds or something.
There's definitely an ecosystem between us and dark matter. I mean, you mentioned that that observation about 400,000 years after the Big Bang, that's these tiny fluctuations in the temperature of the plasma were actually dictated by the amount of dark matter. If there was no dark matter, there would be no seeds of matter density. There would be no, you won't be able to form galaxies or stars or planets or us, right? So in a sense, we are actually a consequence of dark matter. If you build a universe with no dark matter and just baryon, just matter that forms me and you, there would be no galaxies, right? So we'd actually do owe our existence to dark matter in an indirect way, right? And it could be many other consequences of how we and dark matter are forming this ecosystem on a universe scale. But these are interesting questions. Yeah. I haven't actually thought too much about it, but how much of this can we actually probe with our instruments? That's a different question. And at the moment, we're hopeless in detecting dark matter. We need new, fresh ideas on how to measure this dark matter. Dark matter might not even exist. Could be that we don't actually understand the force of gravity, and there's no dark matter. So that's a whole different topic. Yes.
Just from your concept or idea and understanding of dark matter, do you think that there's a possibility that it could have created what this thing is that we call consciousness? I mean, if we are an effect, I've kind of come to grips with that a long time ago, that we're a effect of something. My effect, my birth is the effect of my parents having a fun night or something like that. But I'm just saying, when it comes to dark matter and the universe creation, us being an effect from possibility, I mean, creation of dark matter, I just get to the point of like, do you think that this could be a possibility of this idea of consciousness and how like rapid and misunderstanding a lot of people have? I mean, if you ask people what consciousness is, they can't give you an answer. They can give you ideas of what it is, but they don't have a definitive conclusion of what consciousness is. This imaginative aspect, these many parts of our brain that we can diagnose. There's this one area where we don't have an explanation for this thing inside of us. So I start wondering, do you have any idea, or do you put any weight in the fact that maybe there's a large composite of dark matter that essentially could be the creation in our consciousness?
Well, that's a very deep question. I'm not sure if I can answer it. There's two big unknowns, obviously, the dark matter and consciousness. It's not clear whether we can compound the two, or they could, but there's an open field of exploration, and I think these ideas have been explored, probably not by scientists but by fiction writers. And I there's this book, I think it's called Dark Animals, and there's been also a TV series about this. It's very interesting, where all these ideas are explored about dark matter uh, and consciousness. It's
Heystek,
this book by Philip Pullman.
Heystek, you got anything to add before I go to the next question?
So that's really interesting. So my mind is just springing back to Star Trek and sci-fi, speaking about dark matter. For some reason, I'm thinking about now in Star Trek, where they have antimatter, and where they combine dark matter, normal matter and antimatter to create energy for the propulsion systems of the starship. So that's something interesting I've thought about. But that is also something on a way different sci-fi level.
Well, the reason why I mentioned if we have any tools that can measure a type of, maybe, because I worry about planetary impacts, but what about the concept of cosmic impacts? I mean, if we have something that happens that is not effective of Earth, but something in our solar system or in our galaxy, I start wondering if we have ways to be able to measure what that impact is, that creation is. I mean, we can understand from like what the origins of our planets are composite of the Big Bang. So that was an impact, or that was an explosion that happened. And I start wondering, it brings into my hidden little love for terraforming, because I like talking about planetary civilizations and trying to find these ways to space colonize, these ideas that are in the relative future, I would say. I mean, we're already going to other planets and things of that sort. To think that we're not going to be able to eventually create a base on, or a small little thing, maybe that's another topic for an astrobiologist or something. But I start going, if you're able to detect these types of powerful impacts or these types of creations, a star formation, be able to measure it on even a smaller scale. How long until we start trying to find out the details of what that is? How many hydrogen atoms, how many of this and how many of this cause this to happen? Or you start having someone try and recreate it on a smaller level in a lab somewhere. You're starting to try and create whatever this thing is that essentially afterwards, it might not just be an explosion, but afterwards you have a creation of something where it brings into the idea of terraforming. I mean, the idea I had talked with my buddy who studies impact craters was being able to find one of these asteroids and be able to detect a certain spot to hit one of these planets and make it into an exoplanet. Now, that is a very long leap compared to where we're at now to being able to do that in the future, depending on if we focus in it or not, where I start wondering if they're still sticking around the concept of terraforming. Because I mean, humans, we just want to expand, we want to go out, we want to do things, and I'm 100% for it. But necessarily, I also have a side of me that goes, "Are we ready to leave Earth yet? I don't know. I still don't know how to do taxes properly." So I get to this point where if we can understand or we're able to measure these types of cosmic impacts, um, on a smaller scale, could we replicate it in a sense to where you might be able to fix smaller issues, such as, climate change is a big topic. It's very, very political. I didn't know about until I dived into it. But the idea of, like, I've heard people talk about the hypothesis or hypotheticals of harvesting stars. I know we're not even close to that yet, but I mean, these are all obviously in the field of science. The best part about it is you can skepticize, you can toss out all these theories and everything, and it's interesting to learn about. I love learning about ideas that people, how people's minds work. That's why I like, doing a podcast about it.
So I can jump in, I think, a little bit with this. So think about terraforming and starting to do things on a smaller scale. A good example is with nuclear power. So right now we use nuclear fission reactions. So where we take an atom, you split it into two, and energy is released. But in fusion reactors that's being investigated, that's the other way around. That's how a star makes energy. So in a normal star, beginning with a star, you have hydrogen atoms. You fuse the hydrogen atoms together. That creates helium. And that releases energy until all the hydrogen atoms is used up. And then you have helium atoms left. The helium atoms gets fused. That creates carbon and so forth. But the idea is in a fusion reactor here on Earth, so there are a few designs, not very successful yet, but there are, is why don't we use the same principle here on Earth? You take atoms, you fuse them together, and you get a lot of energy. And if you would do terraforming in the future, and you would need a power source on the planet to help those terraforming techniques using, fusion reactors might be a great way of doing it. And so in theory, we know how to do fusion. In theory, we know if we fuse two hydrogen atoms, we will get a helium atom plus energy. So in theory, we know how to do it. But the problem is we need immense magnetic fields to stabilize that reactions. And that is being tested in labs all across the globe now.
Yeah, I just want to echo what the Heystek said. Actually, this I think will be the future um, for solving all kinds of problems, including climate change and future transportation to other planets, travel, and so on. The rockets that we have now are consume a lot of fuel, and they're not very efficient, right, in terms of like uh, uh, transporting people from one planet to another. But with a rocket, which is fueled by fusion rather than normal fuel, then the whole travel would be sped up. And for example, we can people talk about colonizing Mars, for example, right? That would be it would be faster if the travel would be made with a rocket, which is a fission reactor. Now, I think just a few weeks ago, there was some news on about a fusion reactor being able to have these reactions for about 4 minutes. So there's been great progress lately on sustaining these reactions on Earth. And as Heystek was saying, that the complication is to kind of keep that reaction going and also confining it, right? Obviously, you have to, in order to put that onto a rocket, you have to make it commercially available and to miniaturize it. So you don't have this huge reactor that we have on Earth, but where we speed up all these particles to kind of bump into each other. So you just have it confined onto a rocket, and for that you need this very strong magnetic fields to collimate the plasma. But I think these are technical challenges, and maybe in 100 years from now, this would be already figured out. Yes, and yeah.
I don't necessarily know if you guys have your work hats on when you're answering my questions, but I'm going to ask you to take it off just for this one. Where would you like to see our space exploration go? Because I mean, I don't toss out Avi's idea of sending our digital children up there. I think that's a great idea. Honestly, I think that's probably the direction where we're headed with. Maybe that's just the guests I've had on have all been like transhumanists or futurists that I've talked to that have talked about this digital implementation of technology into our bodies. But I also bring up the question, a lot of the stuff that we do talk about where I do lean more towards the transhumanism aspect is the idea of human error. I think that we would probably be a lot farther if we did have a capacity, whether it's AI to help us or whether it's whatever to help us get us there. We need a tool, much like, you need a cup and you need water. Water needs the cup needs the water for you to be able to drink it. That's a working relationship right there. So I bring up the working relationship with the machines that we create. Now, necessarily, are we going to funnel it into things like space exploration? I'm sure we will, but it's going to be used to something else that's right in front of us as well, too. Some of the interaction. Autonomous vehicles would be the simplest explanation of where it would be headed towards next. I think that's a great idea of using, I don't know, digital reality or using augmented reality and being able to control a robot that's able to walk the surface of Mars instead of having to worry about terraforming Mars. But I also bring up, which direction is a personal question for both of you. Do you think that it would be our idea of understanding that human sacrifice, where necessarily it might not be you that walks that exoplanet or walks that planet or takes that? Because I know a lot of these like Alpha Centauri is like a certain amount of years away. I mean, I don't think we're able to just freeze somebody or bring them. That's a whole other direction that we can talk about. But the idea of, instead of maybe worrying about sending a human to another planet, but sending a human controlled robot to another planet, much like the Mars rover, but in a sense on a better scale, a more robotic scale, a more humanistic featured style robot scale. Because I still bring up the possibility of, like, I don't necessarily know about humans expanding out. I mean, this is still the same question. You think humans want to expand out into the galaxy and go searching for more? I'm sure there's people that would love to do that. Star Trek and all that's about that. But I also go, I don't put it over us to want to change whatever the galaxy is to make it more accompanying for us, which brings up the idea of terraforming, like I was talking about, bringing things closer to us so we don't have to go so far, rather than us going far to go explore something where we could colonize or do something of that sort.
Well, you mentioned the relationship with machines, where they have a lot of, I mean, I'm actually in a harmonious relation with my machines. I do computer simulations all day, and VR, and we apply machine learning techniques and AI. So this is already embedded in our research, and as you say, they are a tool. They're useful tools, and when we want to simulate the universe, it's hopeless to do with pen and paper or just with our brains. We have to rely on machines to kind of, obviously, they're not independent machines. You have to kind of code that up at the moment, but in the future with AI, artificial intelligence, there is also the possibility that AI itself would probe different theories and will help us develop, just much like AI is, like machine are taking over other people's jobs. They could also take over physicists' jobs and come up with the better models of the universe, the things that we haven't actually thought about. But obviously that would be in the far future. And if that would help us understand the universe, I think that would be a wonderful thing. Now, in terms of machine sending for exploration, I think that's well embedded in the philosophy of human exploration of the universe, especially the solar system. You mentioned the Mars rover, and it's already, it has its own individuality. I don't know whether you've seen that the Mars rover has a Twitter account, and it tweets and it interacts with other rovers and with other machines. So there's already this ecosystem of machines out there which is independent of humans. Now, if we want to build settlements on the moon, then we have to send robots there, or machines that would be able to build stuff rather than having humans to service those, like, for example, telescopes, right? Why would you send so many humans and endanger their lives when you can actually send robots and machines? And there's a big field of space exploration it's dedicated to AI and robotic exploration, and I think that would be a great help. Yes, it's a bit difficult to anticipate what will happen in 100 years from now, but obviously think back, where were we 100 years back? Where was just steam, with the industrial revolution and so on, and now we're in the whole different level with the computers and with our civilization, right? So and just a few hundred years back to now, there's been a huge increase in our there was no space exploration 100 years from back, right? So think about what will happen in 100 years from now on. It's very hard to anticipate where the humans will how the humans will develop.
Well, taking off my working hat and what I like to see, I would like to see us as humanity build up like a Star Trek type civilization. And you're going to need baby steps to reach that civilization. But I would like to see in the future, instead of saying going to a vacation on a tropical island, going to the Maldives or Hawaii, or decide you're going to do a bit more exotic, you're going to say, I'm going to have vacation on the moon. I'm going to go to vacation on Mars. I'm going to go to vacation or on a space station around Jupiter, or perhaps on a facility on one of the moons of Jupiter. That is what I would like to see. And what I also think might happen is, I'm a fan of Isaac Asimov. And in one of his short stories, he has the stories where there's two doctors and they are working on operating on a person, but not a life-saving procedure. The person is once a few of his limbs and organs removed and replaced by robotic parts. And then the story ends, the two doctors operating are actually two robots that wants to become more human. And the patient I'm working with is a human that wants to become more like a robot. And I see that as something that might happen in the future as well, that we will use technology to enhance our life and use technology to better the progress of human life as well. And that is what I would like to see happening in the future. But to get to that point, you will need baby steps to reach a space traveling civilization and to have a multi-planet civilization where we will have colonies all around the world. And then, yes, speaking about virtual reality, that will become important in the next couple of years. So how cool would it be if you can take the Mars rover and construct the route that it has traveled to a VR, and you can walk it with VR where the Mars rovers has been, for example. But yes, that is my opinion and what I'd like to see in my sci-fi worlds in the future.
The most important thing I really enjoy about this show is not only the aspect of it being conversation, but also the aspect of I get to see through your experience as well, too. At least the knowledge that you both have consumed through the fields that you work. Mostly because what I brought up with that question of where do you think it's going to go is I'm trying to base our human trajectory in things, especially when it comes to space exploration. And I also look at, like, when we look at virtual reality, which is a topic I've dived in with a bunch of people who are well respected in the virtual reality field, and augmented reality as well, too. And there is a large fear for them when it comes to the idea of how it gets marketed. It gets marketed towards more of business. And I also examine that same relationship with a lot of things. I think the most common example that you two could probably understand a little bit too is with academia as well too. There's industry funded research that gets funded in academia, which might skew results on research depending on what you're looking at. And I start going, is it cool to have a space civil or space habit, form, dome, habitat, whatever you want to say, on Mars? But what happens if you can't leave your pod, your little thing? Is that the same thing as being able to explore Mars? Do you just want to say in the direction when we go and say we landed on the Mars and we have a habitat on there? Is it the idea of to say that we have a dome that you can stay at? Or is it the idea that you can explore all of Mars? Now, I know there's baby steps and there's eventualities of where we'll go. I mean, to think that we're going to be living in a dome 100% when we go to another planet that might have low oxygen levels or something like that. Well, I would think they would develop a capsule. You could take it one day and, 24-hour oxygen or something of that sort. So you don't have to worry about putting on a dome or pressure or all these types of things that we'd eventually fix. I give weight to the idea of innovation once we get there. But I also I want to make sure that it's headed in best intentions. And I think through me and Heystek's talk, whenever we bring up colonization on another planet, I've had chats with people who study space law, which I didn't know was a thing. But there's a lot of issues when it comes to this idea of colonization. Whose rights is it to colonize on the moon first? Who owns this? Would it be a United Nations type deal? Would that be the whole world coming together to understand that in space there's different rules than we have on Earth? And I think these are all really good ideas and perspectives, because I think it plot points of, we might say 50 years, we might say 100 years from now, this is where we're going to be. But with the also depending on which direction we're going in. I mean, do you want your billionaires like Elon Musk, which I don't have a problem with at all? I like that they're doing stuff, but I also don't want them to be the main frontiers when we look at of like space colonization. I also want to look towards, a more sustainable things, rather than if you just have a bunch of money, you can go to Mars and stay there. I want to find ways that there can be this idea of, maybe I'm more research focused. Like I would probably like to see more astrobiologists and people who spend all those times in the middle of the desert trying to prepare for staying on Mars in a small little, test facility, whatever you want to say. I'd rather see them go and try and pull out more research and information to make it more, I guess, understanding of us when we go up there, rather than just a bunch of people staying in a hotel on Mars. But they're all interesting ideas. I think they're all very interesting concepts, trying to plot the trajectory of humankind and its expansion outward, and also its, colonization on the planet that we are on here today. I mean, our buildup is fascinating to me. I mean, the past 100 years do not look like today. The past 200 years do not look like today. And you just keep going farther and farther back. And you can kind of examine that, at least how I bring my eyes forward. I'm not trying to tackle this from a philosophy aspect, but I'm also looking at it as like, when you really understand all the information or all the bits and pieces of perspectives, you really get to see the picture a little bit more clearly. Where I just go, I mean, there's a lot of people that don't even think about this. There's a lot of people out there that just want to go to their job and worry about what the price of gas is, which is okay. I'm not yelling at them about it, but it's interesting to see just the trajectory of where we'll be from here on right now to where we'll be 5 years from now, 10 years from now, where just a random idea could come in at the last minute mark, like how we are fourth quarter people. We're not good at long problems. We're good at problems that attack us as soon as possible, and then we fix it, and then we go over to the thing. That's why climate change is such a difficult issue. It's a long game is what they're saying. That's why they're trying to push it now, which I get. But I also think this is an important part about, the human experience that we're all in. I don't know what that human experience is going to be 10 years from now, 15 years from now, 20 years from now, but it's just interesting where I wanted to get your thoughts on that.
Yeah, I think you raise a lot of good points there, and there is a feeling that this is, I mean, there's a lot of talk about space lately and exploration, and that also goes hand in hand with the advances on technology and computers and AI. And there's a lot of developments which give you the feeling that everything is going a bit too fast, and possibly the the ethical aspects are not very well thought of. People just think about, let's innovate first and think about the consequences later. So I think you probably need a lot of people to kind of, especially for these big endeavors, like going to a different planet or even the moon, I think. But I'm also very hopeful. I think, and fortunately, I think all these enterprises are so big that no single individual could be responsible, or no single company. So that I think you have, and also we have different players. We have NASA, ESA, the European Space Agency. We have the Chinese and the Russians, and India is also an emerging space power. And again, it's hard to anticipate what will happen in 50 or 100 years from now. But certainly we need better regulations and better, we have to kind of change our mindset. We can't just go up into outer space and just continue whatever issues we had on Earth, right? We cannot just transport our earthly problems onto a different planet. There has to be a lot of more thinking. So maybe not just the scientists, but everyone else has to be involved, like, people who think about ethics and about human conditions and so on, and human development. And let's not forget that the Earth it's a wonderful place. It's our home, and it's probably the best planet in, that we can ever find. We have to take care of it.
I think you change somebody's experience or their mindset when you show them what it looks like all the stars. Like if you see like someone through a high photo lens of like the Milky Way and they just take a picture in their backyard, we're like, this looks fake. And trust me, I found plenty of them on Twitter where I'm like, this is fake. This is this app. But there's some people that take real photos and actual photos of the sky at night. And when you see that, and then you look up in your backyard and you take a picture through your iPhone and you don't see any of that, I think that's something that can really change. Like you need one of those, like what I wouldn't call it a spiritual experience, but you need to see something that's bigger than yourself in a sense as well too. And I think that has to be the priority of what you're showing to a bunch of people as well too. That's why I think it's so interesting when Neil deGrasse Tyson or someone comes out and does like a public speaking event, just so you can understand through the lens of what that person sees probably on a daily basis or thinks about on a daily basis. What's the importance of you two joining me on this episode today to be able to talk about this type of stuff? You're taking me in through maybe some hypothetical questions that I have, but you're also, talking to me through it, and you're kind of understanding and trying to tackle the concept that I bring up, which is important because I think that's the whole interest of where it gets started, where it gets sparked up, where that's the idea and mindset you need to be focused on when you're going into space or when you want to get the whole civilization on board. I just think you have a lot of people that are more worried about what they're going to be tweeting at next or what they're going to be watching on Netflix. In a sense, it's like, I think I brought this up to you before, Heystek, which is when I talked to someone about the younger dryas impact hypothesis, he gave me this great quote. And he said, for the longest time, the astronomers, all they did was look up, and the geologists, all they did was look down, and none of them talked. And it's like an important thing where it's like, yeah, what happens if they just, talked about things, if they shared information, if they had this back and forth data type discussion or this types of information, one person shares, another person shares. It's a storytelling effect is how societies are built. It's not just from information that's being talked to through friends. It's information that are passed upon generations.
Yeah, that is very true. And adding on to Andreea and yourself, we have to take care of Earth. Earth is the only planet we have currently we can live on. Its living conditions is ideal. So we have to take care of Earth. But yes, looking up in the night sky, it's usually quite astonishing to see. I've seen a few things because I'm quite involved with also public outreach where you try and involve people more in astronomy or science, and you set up a telescope and you point it to Saturn, and the look on a person's face when they actually see Saturn's rings for the first time with their own eyes through a telescope, that usually changes the person's perspective on the universe. But yes, that is true. And the more knowledge we get and the more we can share knowledge with one another, the better we can improve human life and the better we can enrich ourselves.
Would it be easier to terraform one of these nearby existing planets to meet the conditions of us, or would it be better for us to manipulate ourselves to be able to fit the conditions? Only reason I ask this question is because I think probably like an hour back, we were talking about Mars, and we were talking about, walking on Mars, or, living on Mars, for instance. I bring up the concept of, you remember when Bill Nelson came out and talked about Venus, and he talked about just below the atmosphere might be livable conditions. So there's two possibilities of making like a sky city or something like that. And then also, trying to find a way to make like a base that could deal with the water that's there. And I start going like to this concept of like, if we're going to the realm of propulsion systems, hear me out. I'm just saying, is that a possibility to make a sky city? Because that would be interesting.
In the future, it might be. Then it'd be something like Star Wars. We have Bespin Cloud City.
Yeah.
We don't have the technology yet to do it, but that would be quite amazing. But it's quite interesting to see in the future to terraform a planet or to change ourselves. But I think it will be perhaps a combination of both to live on different worlds.
Andreea, did you have anything?
Yes, I think we also have to kind of develop ourselves in addition with developing technology. I mean, obviously, we mentioned climate change. We do have the technology to solve climate change, but there's also a lot of psychology issues that are, intervening into solving that problem. Imagine if we can't actually solve climate change here now and here, how can we actually terraform another planet? I think we have to kind of change our mentality and kind of develop ourselves in the process of developing that technology.
I've hit the area of climate change a lot, even with, I have friends who are climate skeptics, and I have people who on the other side who are environmentalists, people who study the earth and will tell you that it is. I think the concept just has to boil past the idea, is the planet warming or not? Because for some reason that has gotten severely political. And when it comes to that, it's just two sides shouting at each other. So I just bring the topic and I try and change the focus. I'm like, whatever that disagreement is, whatever side you stand on that one, let's just boil down to the concept of finding an alternative energy source. And that's a start. That's kind of headed into the correct direction. I don't necessarily agree that it's nuclear. I'm sorry. I was a big nuclear guy in the beginning. I was like, nuclear. It says it on energy.gov. Nuclear is the thing. But I bring up the human error aspect. You have those nuclear facilities. The biggest problem that I've talked to with people who study that power source and work in like the United Nations or dealing with these concepts that I've had on the show, they say the biggest thing is that people don't maintenance them. They don't regulate them. Now, maybe if we do a prime focus on that, then there'll probably be better regulation on those things. But we have a lot of them that are 30 years past due. And I know people say the Chernobyl example is the toss out of like, you don't want that to happen again. I'm like, I'll leave that one there. I just go, you got to bring up the human error aspect. And I think in a lot of areas, this is where I talk about the human trajectory aspect. Our prime focus in right now in this world, in this society, and I think it's in a lot of cultures, is the idea of making money or progressing in a sense. And now I think that progression necessarily has a weird relationship with business. So I think we just got to make sure like what's more sustainable compared to the business aspect of things. I look at like the long haul of society compared to like, the short financial gain where whoever's making the move is just worried about money in a sense. Maybe that's just me. I don't know.
So that is something interesting. So of course there will be stakeholders funding these sort of things and always want to try and make money of it. But I think there should be a bit of change in the mindset of people. Instead of thinking of how much money you can make of it, change mindset and think of how can you improve human life? How can you do it in the long run to improve human life, to preserve human life, preserve our world? And as soon as that mindset has taken effect to most people, I think a lot of things will change around us.
It's kind of how I see it too. Is there any other things you guys wanted to bring up or talk about before we wrap up? We've almost been going 2 hours, so.
Yeah, time flies. No, I think we covered a lot of interesting stuff. I'm not sure if we have the answer for everything, but it's always amazing to kind of think of all the possibilities of exploring space.
Yes, I totally agree. This was a fun talking session. Now, I enjoyed talking to everyone, to both of you.
I'll have to get Massimo and a friend of mine, Dr. Serene Nemi, who studies supernova, on this with us. We'll do a giant panel about it. It's interesting to me because I get to sit and just to be like, oh, God, I get to bask in all the information because I have no clue about any of it. It's all new to me. It's all interesting too, because especially like, I mean, like I said, when you brought up the multiverse to me in the first place, and I brought it up with Heystek as well too. I mean, that's an interesting concept. I mean, we obviously don't have evidence on that, but I just think it's just an interesting idea because there's people out there that research that type of stuff, and I think that's what I like is that all these theories, what people call theories or ideas, or all these hypotheses that are out there. It's just interesting to see what everybody's like wavelength that they're on. It's completely different from what I would be thinking about. I'm worried about like what I'm going to be doing tomorrow or something like that. If I'm going to take my shirt off at the beach, I don't know. But it's just interesting to me. But I appreciate the time you guys have given me to be able to do this podcast and everything. Andreea, did you want to say where people could find your links, any of your writings on your blog or anything? And then also Heystek, if you want to say yours when she gets done.
Yes, they could find me. I have a Twitter account. They could also find me on LinkedIn and Facebook. And I also have a professional website connected to my home institution, the Astrophysics Research Institute at Liverpool John Moores University.
Oh, and you can find me on Facebook at Heystek Grobler or Twitter just at Heystek Grobler.
And I will link them all in the description. It's been a pleasure chatting with you folks. And I will see everyone on the next episode of Out of the Blank podcast.